So we invited Matt Watts as part of our distribution enablement program, which we've been running for the last 2 days. And I thought it'd be a really good opportunity to invite the local team also to take advantage of while Matt is here. So I'm going to keep it really brief. So without further ado, I'm going to hand over to Matt, and he could go through his vision, his insights, his strategy as to what's going on in the IT world, and what we could look forward to in the future, I guess, right?
Thanks, Russ.
Okay.
I'm mic'd up, I believe.
Thank you.
Just for Christian, that's saying meeting is being recorded. Got it, or leave meeting. Do you need to confirm before it'll actually start recording? It's recording? Yep. Okay, perfect. Fantastic. We're here in Germany, so we start bang on 9 o'clock. I love it. That's proper German efficiency there. If we'd have been in Italy now, well, one more coffee and look, it's fantastic to be here, and thank you to Shiraz and Kinga and everybody for giving me an opportunity to spend a little bit of time with you to share some thoughts and perspectives. It's been a fascinating year. I sort of look back over what's happened over the last year, and there's been some incredible highs. There's been some low points as well, but I think generally, I think we're in a very positive position. And as I sort of look out over what I think the next 6, 12, 18, 24 months looks like, I think we've actually positioned ourselves really, really well. And I'm going to talk a little bit about why I believe that's the case. One of the things that really struck me fairly recently, I know most of you have a copy of the book that I wrote. I was never a good writer. I always struggled with writing. I didn't even pass English literature at school, so it just wasn't my strong point. Over the course of the last 5, 10, 15 years, I improved because I was writing a lot of blog posts, LinkedIn posts, and the book that you've got, The Fourth Wave, it actually started off as The Third Wave because I started writing it about 2, 3 years ago. And it was never intended to be a book. It was just, I had a lot of stuff that I just was in my head that I just wanted to sort of get down on paper. And the more that I wrote, the more that I started to see this pattern emerging, which is where The Third Wave came from. And over the course of the last year or so, I updated it because of the fourth wave, which we'll talk a little bit about. And we decided we'd do something with it. So we sort of put it out there. For me personally, it was a big milestone. From somebody who never really was very good at writing to actually have written, albeit a short book, for me was a major milestone. So, so to continue that thread, I picked up this expression. See if this, there we go. We must manage the ripples and ride the waves. And this again was sort of born from looking at the sort of the things that were happening. And what I mean by this is ripples are things that just happen all the time in technology. We're always seeing higher densities, faster processors, more cores, bigger memory. There's things like that that just happen. And for me, those are ripples. They're kind of business as usual. You have to deal with them. They have to be part of your short and medium-term strategy. And they do create opportunity, but they're ripples. Waves, for me, are industry-changing moments. They're things that create multi-billion, if not even trillion-dollar opportunities, trillion-dollar industries. And if you can spot one, and you can get and it's how you find it, it's all down to luck, timing, foresight, genius, a little sprinkling of all of those things. And if you can get all of those things right, and you can spot a wave, potentially it gives you an opportunity to really do something significant. And like I said, I believe there's been 3 so far, which I'm going to talk through. But one of the trends or one of the patterns that I've seen in the background is that as waves form, we tend to repeat the same 4 steps every time. And it's these 4 things here. We spot a wave coming. We're lucky enough that we've identified it. We're going to do something with it. So businesses go out and embrace it. The way that waves are embraced is typically very unstructured. Different groups see that something's happening and they go out and they do their own thing. So when waves form, people tend to just flock out because they can all see what the advantage could be to them or to their group or to their department or to their company. So there's a very kind of unstructured race to start embracing this new thing. There's huge value. Innovation picks up steam. People within the business see that this wave, this thing that they've been embracing is creating all sorts of new opportunities. But over time, what was once new becomes old. Everything over time just becomes part of the maintenance. It becomes part of what we just have to maintain and deal with. And the value diminishes because now it's just an expectation. And all of your competitors have caught up. So it's not even creating significant value compared to your competitors. And it's typically at that moment that we look at step 3, which is we take a step back and look at this thing that we've built and go, oh my word, we've built a monster. And then we typically try and automate and optimize and standardize. And we go through all of these processes to try and sort of get control of the beast, for want of a better expression. And then we go back to the beginning because another wave starts to form and we do exactly the same 4 things again. Now, it's important to note, I'm not saying these 4 things are wrong. But being aware of them means you can potentially make different decisions. You can make different calls about what you would do. If you think that being able to rush out and embrace this new thing at the beginning in a very unstructured way, if the value of that outweighs the fact that you are going to have to deal with the complexity at some point in the future, then these 4 steps are fine. But would there be different decisions you'd make if you knew that these were the 4 steps you were typically going to go through? That's what fascinates me. The waves became fascinating for me. That's why I wrote the book. But then looking at the patterns and things that emerge behind them, you start to get even more fascinated. So what have the waves been? Well, this is when NetApp was born. We were born into the first wave, which I call modularization. It was... I'm going to ask these questions, and it terrifies me at how few hands go up. How many people were working in IT in the 90s to the 2000s? Thank you. You've made me feel much, much better. So there were a few of us. Yeah. I'm not going to spend too much time talking about the 90s and 2000s. It's a long time in the past, but I will use it as an example. This is when NetApp came into the industry. And again, whether it was luck, genius, timing, or a sprinkling of all of those things, a wave was forming. And the wave was modularization. It was that move away from the monolithic systems that we'd had in the past to these more modular type technologies that are now what we deal with on a day-to-day basis. And NetApp got the timing right. You know, we came into a world of EMC Symmetrics, of HDS Lightnings, of IBM Sharks. Some of you will remember these things. These were huge technical marvels, very expensive, very complicated, very inflexible. So of course, when NetApp came in and said, the way you've been doing things is fine, but it's not the way we'll do things in the future. Luck, timing, judgment, genius, whatever it was, we started a wave. And it took us to 2 billion. So waves create big opportunities for organizations. But if you think about this period, we went through these 4 steps. Many of you won't remember this, but just so that you have the benefit of hindsight, the Exchange team went out and built the Exchange infrastructure using the technologies that they preferred. We did used to run our own email, for those of you who weren't aware of that, in days of the past. The Oracle team went out and built the Oracle infrastructure, the SAP team, the SAP infrastructure, the file services team, the file services infrastructure. And they all went out and chose the technology that they thought was best for their particular task. And the business saw huge innovation. Suddenly, we were bringing in tools and applications and technologies that we hadn't had before. And innovation went through the roof. But over time, what was once new became old, became normal. And then we looked out and go, what on earth have we built? Because suddenly we had Sun and we had HP and we had IBM and we had EMC and we had, I always said data centers from that era, I don't call them data centers, I call them a museum of past IT decisions, which I think is a more accurate description. So we went through these 4 steps. We tried to simplify, consolidate, automate, optimize. So let's get a bit newer. How many of you remember the world before virtualization or VMware? There's a few more hands. That one is the one that makes me feel old, because it wasn't that long ago, as far as I'm concerned. It was 2008, that sort of time when it really started to boom. 2010 was probably the big year for it. So it's 14, 16 years ago since VMware kind of came in. So there's an awful lot of people that weren't there. So there's an awful lot of people that don't remember that we went through the same 4 steps when virtualization happened, which was the second wave. And if, for those of you who were there, you'll remember it wasn't always about VMware. We had Citrix, we had KVM, we had Hyper-V, we had VMware, we had a bunch of others that didn't make it. And most of us used all of them because the desktop people liked Citrix and the application team liked VMware and open source team like KVM and the people who were paying for it liked Hyper-V because it was being bundled and everything else. So for lots of different reasons, we embraced lots of different virtualization technologies. The business saw huge value from it. No denying it. It drove up utilization. It helped to reduce costs. How the world has changed in the last year or so, but it was huge. But the reality was, as we got towards the sort of the middle of this era, as we got towards step 3, most companies standardized on VMware. You know, I think it's fair to say VMware pretty much won the war, although there are still a lot of skirmishes going on. More, I think, will happen in the future. So then cloud happened. And we've done the same thing again. Now, of course, different companies are at different stages of this process. So it depends on who you are in terms of how far into sort of cloud that you've gone. But we've done the same thing again. The developers like AWS and the AI team like using Vertex AI inside Google and the application teams like using Azure. So suddenly we've ended up with what I like to call an accidental multi-cloud, which it kind of wasn't what we planned, but we kind of ended up with it anywhere. And the business is seeing huge benefit from it. But at some point, and we're starting to see this now, people are getting towards step 3 and looking at it and going, we've done it again. So now we're going through and we're looking at that process of how do we optimize, standardize, consolidate. And that's what's fascinating for me. And I think it's where it really positions us that as an organization, we truly believe that companies have to have an intelligent data strategy. And it's underpinned by this idea of intelligent data infrastructure, which I'm going to talk more about. But what's the opportunity? Because that's what we're all here for, right? We're here because we like doing the things that we do. We're also here because we like to get paid for it and work for a company that has the successful future. So I had my team model something. One of the challenges that I've always found is there's so much information out there. It's very difficult to get an idea of what's actually happening. Some of you will be aware that we have this idea of 4-3-5, which is that we have effectively 5 key workloads that we're focused on, 5 kind of growth workloads that we're putting a big focus on for going forwards. And these are them: AI, VMware, ransomware, SAN, and databases. Those are our big 5 kind of focus areas. On top of everything else we already do, these are just ones that we think need more focus because they create a big opportunity for us. One of the challenges with this was when I go and talk to the VMware team, they say the VMware opportunity is 12 billion. And then you talk to the SAN team and they say, oh, the SAN opportunity is 10 billion. So we have a total addressable market of 22 billion. No, we don't, because VMware runs on SAN. It's the same market. And what I'd never seen was this idea of, can we actually present what the total addressable market is for all 5 of the workloads and remove all of that double counting? What is the actual opportunity in front of us? And the actual opportunity is this. No numbers are exact, but even if this is 10 or 15 or even 20% out, it is still a pretty big opportunity. Those 5 workloads that we're focused on, which is where intelligent data infrastructure really gives us a key, give us an addressable market of an additional 33.5 billion. So the future's pretty bright in terms of our opportunity. And I just wanted to put that up there because I think sometimes we talk about these 5 workloads and sometimes we don't give you the context as to why those 5 and why are those the ones that we think are the most important. It's because it's $34 billion worth of addressable market for us. So I just wanted you to have that context. Some of the tenets of what we're doing, we think about intelligent data infrastructure. One of the areas we talk about is simplicity. And I should have given you this slide right at the beginning. This is my cloud bingo slide. I have heard every one of these terms being used. I did not make this up. I have some personal favorites. I think supercloud. Who isn't going to buy supercloud, right? Hypercloud, yes, because what technology isn't better once you slap the word hyper in front of it? Done that before. So all of these are true terms that people have been using in the industry. They come about for several different reasons. Analysts who get paid big money for these things try and come up with terms and ideas so that they can be seen as the one that led the way, that had that real insight. Vendors like ourselves come up with these things to try and make it look as if we created them and we were the company that led the way in terms of these new things. The reality is, whilst I'm a little cynical about these, I'm British, that's in my nature, I do look at them and as a futurist, as somebody who's trying to look and see what's the wave, what's that next thing, what's more interesting for me is what's behind this. If all these terms are being used, is there a common theme? Is there a common thread that kind of runs through all of these things? And the answer is yes, there is. For those of you who, there was about a third of the room, I think, said you remembered the world before VMware, right? About a third of us. Go on, let's make it a half. That makes me feel better. It was a half of us that remember the world before VMware. For those of you who do remember it, you'll remember what it was like. For those of you who weren't there, so you don't remember it, let me tell you what it was like. It was horrible. It was just so complicated. We had, Solara and HPUX and Sun OS or Solara. We had different operating systems, different applications, different technology stacks. They were underutilized. We had to back them up. We had to try and secure them. It really was, a challenging environment for us to work in. And VMware solved that problem to some degree. They came in with this promise of we'll increase utilization. What they ended up delivering for us was so much more than that, but they came in to effectively address this problem. What fascinates me is this problem is coming back. It's just manifesting itself in a different way. And many of those problems that we previously solved have come back with it. We've now got cloud stacks rather than technology stacks. You've got the Azure stack, the Google Cloud stack, the AWS stack, plus whatever you've got on premises. And we're starting to see it's very complex. It's highly risky. You are increasing the blast radius. So it is something that has a higher level of risk and security. It's very resource intensive. There's a massive IT skills shortage at the moment. We are in a very fortunate position that our industry has a huge skills shortage. In the US, there are currently 2 million unfilled IT vacancies in the US, IT roles in the US. And there was some research done fairly recently, I think it was by IDC, that believed that could cost the US economy $7 trillion in lost productivity and quality. So it's huge, right? So then we look at what we're doing and we think, well, we've got a lot of very resource intensive tasks that we kind of have to perform just to maintain things. And it's hugely inefficient. 250 billion is currently spent on cloud, and the estimates are about 30% of that is wasted, which is just massive numbers. So that's the bad news. What's the good news? The answer to this is not more virtualization. VMware will tell you the answer to every problem is more virtualization. Virtualize the clouds, virtualize this. That's the answer to all the problems. I don't agree. The reality is that virtualization is just one of the environments, one of the applications that people have to deal with. It's not all of it. So when I look at that and I think VMware solved this problem for the second wave and built themselves a $61 billion business by doing that. What does that represent? If the answer is not more virtualization, what is the answer? It's standardization. And I look at that and I think, what if you could run one way of storing data, whether it's on premises, natively inside Azure, inside AWS, inside Google Cloud, one way to store, protect, manage, encrypt data, regardless of the cloud and regardless of the application, whether it's VMware, whether it's containerized, whether it's elastic, whether it's native, doesn't matter. That's pretty powerful. What if I could also give you tools that would enable you to automate the way that you set up applications, the way that you optimize applications for any application running inside any one of the clouds? And what if I can give you a single view, a single pane of glass that allows you to look into and understand what your hybrid multi-cloud infrastructure looks like? That's pretty powerful. And if we do that right, unified storage is now more than just any protocol. It's any protocol anywhere. It's having optimization, intelligent services. We are leading the way in terms of things like security right now. I think that's one of those things that we did really, really well, was invest in it and get ahead of it. And I think we've put ourselves into a good position around security. This is why, if we get this story right about intelligent data infrastructure, to do that, how big is the opportunity? VMware built a $61 billion business from their opportunity. Do I believe this is a $61 billion business? Probably not. But what if it's 50% of that? That's 30 billion. That's huge. And it's why I'm so excited about where we've put ourselves. The things that we've been doing about putting NetApp into the clouds as that first-party service, we didn't do it for this reason. We did it because we knew it would create incremental revenue opportunities because people would want to use enterprise storage in the different clouds. I said it right at the beginning. It's a mixture of luck, timing, genius, judgment. All of those things have to come together for an opportunity to really come towards you. And I think because of all of those things, it's put us in this really fascinating position. Now we've just got to get out there and make sure everybody knows about it, that we're telling the story. I think from a security point of view, I just touched on it briefly. You all know the story, so I'm not going to go through it in a lot of detail, but I think if you certainly compare us to our competitors out there in the industry, I think it was fantastic that we brought everything back together and just said it's ONTAP One. So, you know, everybody gets all of the features. There's a lot of ongoing investment. You'll know as we get towards 9.15, we're going to see the AI-based autonomous ransomware protection. So there's lots of stuff coming here. So I think this is really good for us. And again, it differentiates you. You know, we are a premium product. And therefore, we need to let people know that we have premium features because we are a premium product. And this kind of capability is a really good example of those kind of premium features. So I think, again, really good part of our story. So I've talked about the third wave. How long am I into this now? 22 minutes in. And what haven't I mentioned so far? AI. Here we go. So the rest of my presentation, no, I'm not joking. I'm not going to spend the rest of the presentation talking about AI. But you're absolutely right. When I first wrote the book, when it was the third wave, what's fascinating about it is no one wants to know about the three waves. The only thing they want to know about is what's the fourth wave. So when I gave the book out, it was what's the fourth wave? Or people would say AI is the fourth wave. And I was quite hesitant about it. And the reason I was hesitant is there's a characteristic that has to happen for a wave to form, which is democratization. If you can't make a technology available to the masses, it can never become a wave. It's just an interesting technology that a few people will benefit from. And for the last 2 or 3 years, we've not had a lot of data scientists. We've not had a lot of skills in AI to be able to democratize and create that wave. And then, of course, in November last year, ChatGPT happened. And within the space of 2 weeks, we suddenly had 200 million AI experts in the world, which is interesting and another challenge in its own right. But that was the moment. The programming language for AI was now that you talked to it. And I think AI is in an interesting position. I think next year will be a really fascinating year for AI. I think we will hit what Gartner like to call the trough of disillusionment. I think at the moment, there's a lot of talk that AI is going to solve the world's problems. It's going to fix world hunger. It's going to solve world debt. I think the reality is that a lot of companies are going to go, oh, is that it? Or a lot of those projects that they thought were going to have these massive changes, these massive impacts, are going to be much less than they first expected. So I think there is going to be that normalization next year. And then we'll come out the other side and people will reset their expectations and we'll start to see the real kind of AI projects, the real value, the real level of value will start to come out. So I think we're in for an interesting year with AI next year, but it is definitely the fourth wave. And by the way, we are repeating exactly the same 4 steps again. Because lots of different groups can see the value of AI to their part of the business, to their department, to their company. And they're all going out and using different tools. I like SageMaker. I like Vertex AI. I like this. I like that. And we're going to see that there will be huge amounts of innovation there. Once we get through that sort of that normalization next year, there's going to be lots of innovation around this. But at some point, we will hit step 3 and then step 4, which is what was once new becomes old, becomes normal to us. And at that point, we look out across what we've built and we'll go, we've done it again, which I think is fascinating. But I think it also ties back into the story that I just told about standardization. What if you could use the same underlying technology to be able to store, protect, manage, encrypt the data? You choose whatever tool sets you want to use in whichever cloud you want to use them in. But let's not build that complexity of having multiple data silos because different teams are making decisions about which technologies they want to use. And I think that's really where, as we think about smarts, which is a key part of intelligent data infrastructure, you'll start to say, again, we don't care if it's hybrid cloud, public cloud, private cloud, hyper cloud, super cloud, whatever you call it, we can give you a solution that's intelligent, integrated, scalable performance, and trusted and secure. So I think, again, very good opportunity for us as we start to think about AI as a workload. This has become part of the wave. So there's a lot of these sorts of things which aren't waves in their own right, but they become sort of elements of a wave. Sustainability was something I got involved with. It's going back about 5 or 6 years ago now. Part of my job is to look at that kind of what's coming, what's next. And there were just a lot of indicators. There were a lot of things that were telling me that, sustainability was going to be important. And out of interest in this room, how many of you are having sustainability conversations right now, or have customers that are starting to have sustainability conversations? A few? Okay, yeah. So I think it'll become more as CSRD, which is the Corporate Sustainability Directive, starts to really kick in and people have to report on it. I think we'll see a lot more of it as well. But why is it happening? Why is it happening right now? There's 3 reasons. I remember doing this presentation. You have to be careful how you talk about sustainability. It can be a bit of a partisan topic. So I'm quite careful to say, I have my own beliefs. You don't need to know what they are. I'm not going to inflict them on you. I'm just going to give you the facts. The reality is there are 3 reasons why companies are looking at sustainability. First one is people. There is a generation and people within our generations that want to work for companies that represent their values. And therefore, if as an organization you choose not to address sustainability, I already said there's a talent shortage, there's a skills shortage. If you choose to do nothing about sustainability, you're limiting yourself even further in what is already a limited talent pool. That's reason number 1. Profit. Companies, big companies making net zero goals, that means their supply chain has to be net zero as well. So does it give you a preferential position in the supply chains over your competitors? Yes, it does. So again, companies will do this because they want to be part of these huge supply chains where net zero is the goal of the company that's at the head of it. So that helps with profit. And then finally, this planet. Again, you can see the headlines. We're heading towards not 1.5 degrees of warming, and now talking about 3.1 degrees of global warming. Whether you believe in that stuff or not, you're entitled to your own opinions, your own views. But there is a lot of people who will be doing this because the planet is something that they care about. It's top 10 list of CEO priorities, and 20% say it's top 5. There are huge budgets and investments being put to one side for sustainability, for those kind of projects. So what does it mean? We look at the scale of the problem. In 2025, we will create 175 zettabytes of data, which is a lot of data. It puts us on a path to hit the yottabyte problem by 2030. Everybody knows what a yottabyte is. Yeah, there's a few technical people there. Well, just in case you don't, it's 1 trillion terabytes. Let me make that really realistic for you. That is the equivalent of every single human being on the planet carrying 500 iPhones. That is how much data, the global data sphere, that is every piece of data created by everything that can create data. Now, we can't directly affect that, right? That's outside of our control. But what is within our control? Data centers currently consume about 2% of the world's electricity. It's funny, there's a little data center just over the road here. I spotted it as I walked in this morning. The power that's being consumed by that data center is the equivalent of about 10,000 households, to give you some context. This whole area around us consumes less power than that one data center does. They forecast that power consumption for data centers could go up to about 8% as we look out towards 2030. And I've had people say, no, it's never going to be that. Go and speak to the Irish. Data centers in Ireland consume more electricity than the entire urban population. And they're now having to put a moratorium on building more data centers because they don't believe that they can actually generate the power that's needed for this. Let me give you another example from Ohio. I don't think there's anyone from Ohio in the room. I'm not picking on Ohio. This was just a story that I happened to read. There are 50 companies that have applied to build 90 data centers in Ohio, and they're all on hold at the moment. There's a huge case being taken to court about this at the moment because the Ohio Power Company said for us to supply that quantity of electricity, we have to invest hundreds of billions into the infrastructure. And we're not going to do that if you don't commit to having a long-term energy consumption plan. Because you could build all these data centers and you could all disappear. And we're left holding the bill for the infrastructure. So what they're saying is at the moment, they want companies building data centers in Ohio to pay 90% of their energy bill or commit to it for 10 years up front. It's currently 75. That's been agreed. They're now asking for 90. So I looked into it and I thought, well, how big an issue is this? Currently, the committed capacity for data centers that already exist in Ohio, if they just meet the current commitments, it's about 4,000 megawatts of electricity. The additional 90 data centers will put an additional load on the network of 30,000 megawatts, which is the equivalent of 20 million households. That's just in Ohio. Now we go back to the sustainability problem. Again, I'm not picking on Ohio. This is just, it's stating fact. 96% of their energy comes from natural gas and coal. Now you start to see the problem. So it's going to become more and more of a topic of focus. In the UK, they've just declared data centers critical infrastructure. The reason they've done that is we can't stop them from being built. They have to be built now. They're as important as anything else in the country. We'll see more countries doing that. But what can we do? What's sort of the opportunity, the responsibility that we can take on from this from a data point of view? Well, storage is currently about 20% of data center power, there or thereabouts. This was forecast from IDC that says that could get up to about 38% if we look out over the next time period. We're not seeing capacities grow at the same speed as we're seeing CPU, GPU increases, and we are creating more and more and more data. Even if it's not 38%, it's still pretty significant, right? So you can start to do the maths here. If 8% of the world's electricity is going to data centers, let's say 30% is going to storage. We're now 2.4% of the world's electricity powering storage devices, of which 2/3 of the data that we store is a gigantic landfill of garbage that we do nothing with after it's been created. 1.5%, 1.6, 1.7% of the world's electricity will be going to power storage devices that are storing data that we never, ever use again after it's been created. That's a huge opportunity. And I think two things will likely happen. I'm not saying it doesn't have value, but we don't know how to unlock the value. What if we could vectorize it and start to talk to that data? Could we learn something from that data? So I think that will happen. People will start realizing if that's 2/3 of what we have, we do nothing with, is there something we could do with it? And then I think the second thing that will happen is people will look at it and say, well, we need to get better at data management. And we haven't solved this problem in the 30 odd years I've been in the industry, but I think we're going to have to. At some point, we can't just keep consuming, paying for, powering this quantity of stuff when there's this amount of the data that we store on it is simply never used. I met with 2 finance accounts last week in Paris. Their number they said was probably 80%. 80%. I mean, it's just massive. So I think there's a real opportunity there. Now, there is a certain orange-colored vendor that will tell you the answer to this problem is more efficient storage. If the problem here is that big, the opportunity for using more efficient storage is somewhere down there. But if that's all you do, then you make that thing sound like the most important thing in the world. The reality is it's not. If you think about how do you consider energy usage, how do you start to think about this going forward, you need to think about 4 things. 1, look across your entire data center. 40% of the power goes to servers. There are a lot of comatose VMware systems. There's a lot of waste inside that area. That's a good place to start. Look across your server infrastructure. Look across your networks. Look across the storage for unused things. That's a big opportunity. Look at the data. 68% of the data that we store is never used again after it's created. That's an opportunity. So let's look at that as the next thing. Use the public cloud where it makes sense. I'm very careful here because the public cloud vendors' claims are not always quite the reality in terms of energy consumption, in terms of efficiency. So just be careful. They do have and offer an opportunity, but just be cautious as to which region, those sorts of things you're looking at. And then, once you've done all of those things, then make sure that whatever technology you do put into your data center is the most efficient technology that you can use. But starting here means that you are addressing that bit of the problem rather than that bit of the problem. Very clever marketing, but it is misleading. But that's what we come to expect. And that's why I talk about this. Because when I am in that discussion and people are saying, you know, Pure says their storage arrays are create 95% less emissions than the competitors. Bullshit. Did I say that? It's one, it is, and 2, let's put it into context here that it's this part of the problem. Why are we spending all of our time arguing about this when we should be talking about the rest of it? So I think this just gives us a better way of talking about this problem at the scale that really matters. And that's why we have all of these things. I've only picked on 3 of them because I didn't want to spend all my time talking too much this morning. But you can start to see that the big challenges that people have, intelligent data infrastructure is really starting to lean into these things and create these opportunities for us. So I'm preempting the question that I thought would come after doing this presentation. The 5th wave. Which is, it's human nature. You say this is the 4th wave, and people go, "What's the 5th one?" And so it's fascinating because I talked before about AI, which is it's been there. Turing developed the Turing test. It was in the 40s or the 50s. I think it was the 30s or 40s, right? AI is not a new thing. We've had the sort of the Turing test and the stuff that Alan Turing was working on back in those days. We've had the start of AI projects. Anyone remember Clippy? Which God, that was Microsoft's. It was Microsoft's assistant. It was the little paperclip. That's right. Yeah, that was their sort of first introduction. If we're going to change the world with AI, and we got Clippy. So there's always a kind of a boom and bust as we normalize these things. So AI has been there for a long, long time. So why didn't it form a wave? Why was it 2023, 2024 before the wave started to form? It was the democratization. So again, you can look across the industry and say, I think this is going to be a wave, or that seems big enough to be a wave. But you also have to bear in mind that it's not the technology that's going to hold us back. It's not the technology that's going to be the thing that stops a wave from forming. It's going to be our ability to democratize it. And then the level of impact that technology is likely to have. So one of the things that my team does, I showed you the magic roundabouts earlier on so that you could see kind of how we visualize data. We do another one for future technologies. So we have a magic roundabout that allows us to take information from Gartner's hype cycle, from the kind of the datascapes, all these different things that we get, and from customer meetings. So we can take massive amounts of input as to all these technologies that are coming towards us, and then we build a magic roundabout. And we map those technologies back to the things we care about: infrastructure, cloud, AI, cybersecurity, and one that I just call emerging, because it's sort of a more generic kind of placeholder for it. And then we map in all of the technologies. The width of these is the potential impact. How significant are they? What's the actual opportunity associated to that piece of technology? The horizon, simply, when's it likely to happen? These are McKinsey horizons. So, you've got sort of first horizon is currently probably happening right now. Second horizon, opportunity, growth opportunity, probably 12 to 24 months. And then the third horizon is that sort of, it's much more speculative. So if I'm thinking about a wave, I can pretty much rule out the first one. I can pretty much rule out the second one. I need to be looking at those longer term things that are more horizon based. So what do I think the fifth wave is going to be? Anyone want to have a guess? Sorry? Yeah, I agree. I think the promise of quantum, which is now really starting to happen. IBM just launched their Quantum System 2, which is 1,000 qubits. It's modular, so they can now plug these in together to keep doubling the amount of qubits. 1,000 qubits is still nothing, right? It's still a very small amount. We need to get up to tens of thousands, hundreds of thousands before we can solve real problems with them. But it's happening. There are a lot of challenges. The biggest challenges currently are: what type of quantum technology do we use? We've got trapped ion, we've got photonic quantum. I met a company called Orca Computing. Richard Murray is their CEO. I met him in the UK a couple of years ago. He's working on trapped photon. So effectively, they are able to isolate a single photon and then use that as the qubit, so they can change its state. That operates at room temperature. They are pizza boxes, which is really weird when you think of what a quantum computer looks like. I don't know how many of you have seen one, the Quantum System 2. They're these incredible chandeliers, because you have to address each qubit with its own microwave pulse in order to change its state. So at the bottom of the chandelier, you've got the quantum processor, and then every tube and every pipe is effectively so you can address the qubits inside it. Quantum is not a faster form of computing. It does deliver faster results, but that's not what it's about. The reason I think it's going to have such an impact is that if you think about high performance computing, it's all about brute force. You give a high performance computer a problem. If it doesn't give you the answer you wanted, you change the parameters, you run it again. And it's literally how quickly, how much horsepower can you throw at that problem? The way that quantum works is that when you give a quantum computer a problem, and we have to have enough qubits for us to be able to encode the problem onto, but once you give it a problem, it solves for every permutation of that problem at the same time. That's fascinating, because you can now start to think of, well, what if I could use a high performance computer to prepare a problem, throw it to the quantum computer that can give me all of the potential answers, and then I use the high performance computer to identify the one that best matches the scenario. Really good example, very simple example, GPS. When you say, I want to get from point A to point B, the way that GPS does, it works out the first route, and then it goes back and it calculates the second route, and then the third route, and then the fourth route. And then you get to decide which is the most appropriate based on which one has my coffee shop on the way, which one can I use the Autobahn and do 150? And, so you get to make those choices. Very similar with quantum. It'll be that same sort of process. The possibilities that opens up for us are endless. The sorts of problems that will be able to solve once we get the number of qubits we need are fascinating. We don't know how batteries work. We can't simulate the reactions that are happening inside a battery right now, but we potentially could if we could use quantum. So I think from that perspective, quantum also has a feature or a characteristic called entanglement, where you can have two qubits that can be effectively entangled. You change the state of one of them, it changes the state of the other one. They're already being able to do that. China have already experimented with this and are being able to do this over vast distances. So does this mean we'll see quantum networking? Yes, it does. Quantum could be that next solution to how do we create the next generation of very, very high performance networks. And then the challenges. Currently, IBM's Q System 1 which is trapped ion, you have to drop it to minus 270 degrees. If you've ever seen one, it's beautiful. It's this beautiful glass, huge glass box. And in the center, you have the photonic computer, the chandelier hanging down, which is cased up. It runs at minus 270 degrees inside the system. And they are very sensitive to interference. If you knocked on it, you will affect the state of the qubits, which will compromise the results. You could give it the same problem, and you'll get a different result every time if you introduce interference. So we've got a temperature problem, and we've got an interference problem. There's not many data centers that can run systems down at minus 270 degrees, but we'll overcome that. That will get solved. The biggest worry that I have, and one of the reasons why quantum for me is sort of there on my radar and something I'm talking about right now, is what they call a crypto extinction event. Encryption is a parallel problem. The reason we can't break encryption at the moment is because we don't have the systems powerful enough to be able to go through the 10, 20,000, 30,000, a million iterations to be able to come up with the answer. That's what quantum does. If I can put 256 AES encryption into a quantum computer and say, give me the answer, it will give me the answer. The reason we have to be concerned about that, because we need to start thinking about quantum proof algorithms. So, you're saying about quantum being the future. I completely agree. And we need to think about it right now. If you think about a military project from the US, it probably is in design for about 10 years, typical military aircraft, 10 years in design, 25 years of operation, maybe a little longer with relifing. And then the data typically stays top secret for another 15 years after that. That's 50 years. If I'm a bad actor, I just want to get hold of your encrypted data, and I will wait. I will wait until there's a quantum computer powerful enough for me to decrypt it. And that could happen in the next 5 to 10 years, which means your data that is top secret that you think is secure, I will have that for 40 more years, whilst you still think it's secure. So it goes back to a big focus for us. If you kind of tie some of these things back, security is a huge focus for us. And I think what we'll start to look at is now, how do we start to get these crypto or quantum proof algorithms as we go forward? So definitely, I think quantum computing is a great opportunity for the future. So let me leave you with a couple of thoughts. What does this all mean for storage? Right? We've talked about a whole bunch of different stuff here. I think it does relate. Quantum is going to give us security issues, encryption issues, which we're going to need to consider, et cetera, right? Quantum will also be available across the clouds. So again, I think intelligent data infrastructure, that common sort of storage foundation, as Amazon, Microsoft, and Google build out their quantum environments, I think it's going to be also very powerful for us. Quantum memory is coming. Fascinating. Qubits at the moment, it's very difficult to get them to hold state. You've all heard of Schrodinger's cat. I'm sure you've come across the Schrodinger's cat. Yeah, there's a cat inside a box with poison. You don't know if the cat is dead or alive until you open the box. That's quantum. That was a play on the idea that you don't know what state a qubit is in until you look at it. And then when you look at it, it then forms a state. They're looking, can we stabilize that and then use it as persistent memory? That's fascinating. Time crystals. Anyone come across time crystals? This one, they actually used a quantum computer, Google's quantum computer, to simulate a new material. And the simulation was that if you take this material down to minus 270, atoms stop spinning. It's minus 270 degrees, atoms all point in the same direction. What they then did was introduce an energy pulse, which started the atoms spinning. And then they removed the energy pulse. And the atoms continued to spin. And they call them time crystals because they believe they have simulated a new material that has perpetual energy. Could be something, could be nothing, right? Atom-based storage. Currently, it's 100,000 atoms to store 1 bit of data. And we can, and IBM approved it, you can do 1 bit per atom. That's kind of interesting. Some of you will have come across this, DNA storage. I actually met with the German gentleman, actually, who's leading the project at the Imperial College in London. He's leading DNA storage as a project. That entire data center over there, the storage would fit into that if it was DNA. In fact, probably 20 of those data centers' data would fit into that if it was DNA. The potential is huge. His view, when I spoke to him about it, he said we need 5 billion and 5 years. but no one seems to want to invest in it right now. But it's very real. We can store data on DNA. We can recover it. The problem with all of these things comes down to conditions, temperature, speed, and the one we always overlook, error correction. If you think about one of the most unbelievable capabilities inside a storage array, it's error correction. Our ability to know that did what we thought we wrote, is what we thought we wrote actually what got there? And if it gets damaged in any way, can we fix it so that no one knows that there was an issue with it? There have been some breakthroughs around error detection and correction, particularly when it comes to quantum, but we're still a little way off it. But these technologies will happen in my lifetime, in my career. So there may be an update to my book coming, but it'll take a while. So I'm going to leave you with this. It's very easy to look at these things and kind of think, oh, it's so far into the future, it's never going to happen. There will be a few of us in the room that will remember the IBM 3380. My first job was working at British Aerospace in Filton. So that would have been when I was 16. And we did have these inside the data center. These were the storage devices available at the time. So 8 of these was effectively 20 gigabytes of storage. That literally is as big as it looks. That would have stretched from one side of the room to the other side of the room. $1.2 million roughly, at about 2,000 kilograms. 2024, we now have 1,500 gigabytes on something the size of your fingernail, which costs about $150 and weighs 0.5 of a gram. And I'll leave you with some real context. That is about 1/3 of the size of the on-off button on the IBM 3380, which I think is about all of the context you need. So I know I've rambled about a lot of different things there. I hope there's been some interesting stuff in there. I hope you've got a view as to some of the things that we're looking at. I've been at NetApp for almost over 19 and a half years now. And I think the reason I've been here is probably twofold. One is I always find sort of a new role. I always find something new to do inside the organization that excites me, that I hope has value to the company. I do that in 2-year cycles. If I start to think about, I'm already thinking about what would I like to do next? And then I start working on what would be the benefit to me, what would be the benefit to NetApp, and then I try and convince people to create this role and give it to me. That's just the process I go through. I think it's quite a healthy sort of process to go through. So that's one reason why I'm still here. The second reason why I'm still here is I continue to look at NetApp the very way I did in the first days of me coming across NetApp. I was working for a reseller company looking for a solution, a multi-protocol storage solution. The software we were running, Katia, for any of you who know Dassault Systèmes, had literally just been ported onto Windows. So we needed to have multi-protocol storage. And I came across this little company selling filers. And I remember them coming in, Mark Conway and a couple of the lads came in to talk to me. And I'd never thought of storage as being interesting before. The way that things work typically is the further away from the application you move, the less people care. So your sort of application, operating system, servers, network, storage, backup. And so I'd never thought about it before. Storage was just, well, that's where the data goes. And suddenly I had this company coming in talking to me about we can do snapshots and we can do snap restore and we can do replication and I was like, wow, this is incredible. And then as we look through these kind of waves that have happened, everything is data. Think about that. Everything is data. A virtual machine, an application, an operating system. What is it? It's a file. It's all data. And that is what gets me excited, because if you own the data, if you can manage the data, you aren't just talking about the stuff that's being created, you are talking about entire application environments. So for me, when we think about intelligent data infrastructure, you've got to think about that data as being everything. It's the automation, the orchestration, it's the virtual machines, it's everything. And I think the position that we've put ourselves in as an organization, being the intelligent data infrastructure company across multiple clouds, I just think that's a really exciting place for us to be. Will it be a $61 billion opportunity? I don't know. But even if it was 5, 10, 15% of that, that's a hell of a big opportunity and a hell of a bright future for us. And most of that comes down to you. because you are our distributors, you are our partners, you are the way we go to market. So if we get this right, it will only be by working with you. So that's why I'm so delighted that you have Shrez and Kinga and all sorts of people who put these kind of sessions on, because it gives us an opportunity to share our thoughts, our perspective with you, who are the most important people to us, apart from our own employees, of course. It's been an absolute delight talking to you. I'm not going to end with a thank you. Most of you know how I feel about thank you slides. I will end with an appreciation of what you do for us and the commitment, the time that you've put into being here, for taking the time to listen to me. I will do whatever I can to help any one of you. If you want to talk about any of these things, I'm always here. I think most people will know I try and make myself as available as I can. So feel free to reach out at any point. And I do hope to catch up with many of you as I travel the world over the next 6 to 12 months before I work out what my next role is going to be. Thank you very much.
Any questions? Yeah.
Stunned silence is also fine.
With other technology, there is a counter. I cannot speak very well English. So after VMware
Mhm.
Wave and before cloud, or maybe it's in cloud, there is a containers.
Yes.
Is it another wave, or is it inside
Yes.
existing?
It's this great question. I actually had that exact same question from one of the people I spent some time with last week. So for me, waves are themes. So if you modularization, virtualization, cloud, AI, they're much more kind of higher level themes, if you like, or sort of industry trends. Underneath those are the enabling technologies. So very much I see containers as being one of those enabling technologies that doesn't sit uniquely in any one of them. Containers are an evolution of the virtual machines. People are looking at containers, so it affects the second wave. As people start to look at the cloud and they're starting to look at using containers inside the cloud, it affects the third wave. And AI. You know, a lot of AI projects are also going to be based on containers. So for me, containers are an increasing technology trend or increasing technology deployment model that will enable multiple clouds or multiple kind of stages of different clouds. So it's a great question, you know, and that's always that dilemma of, do you take something that's sort of an enabling technology? Is it enough to become a wave? And I really do wrestle with that. But I think with containers in particular, for me, it's an enabling technology that will help not just one wave, but multiple waves to get to where they need to be. So it's a great question.
I can ask you, I mean, the numbers that they show about the sustainability problems, the consumption of the energy, could they be the limit for the new technology coming? Because, I mean, you showed temperatures very low, things like minus 200 degrees. So it could be so extensive in the consumption of energy. Could it be a limit probably for the future? How do you see that? I'm trying to think that we are coming to let's say at the down point. So this could limit the evolution for the future technologies.
It's a really interesting kind of thought process to go through, because, you know, I gave you the example of Ohio. You know, there is a gold rush on at the moment for people to build these GPU powered data centers to underpin these AI projects. When we're talking about the same amount of power as 20 million households in one state, so that doesn't look at, you know, Delaware and all the other states that they're looking at. We have a power problem that we're going to have to solve. We're seeing Microsoft have recruited somebody who's head of nuclear power, so they're looking at, you know, portable or small scale nuclear reactors. That might be part of the solution for this. So there are a number of things that I think that concern me as we sort of look out. I think the power one, the emissions challenge, you know, a lot of those could be the ones that hold us back. It might not be a skills problem. It might simply be we just don't have the resource. In Ireland, they're stopping building data centers. They're now saying no because it's once you get over 21% of the country's electricity going to data centers, then it was never designed to do that. I think even in Holland, we got people from Holland. Yeah, it's yourself there, two of you. Is it Microsoft's data center, which was blocked recently? And then it introduces all sorts of domestic issues because now the farmers are being told you can't have as many livestock because we need to reduce the emissions, but we're going to go and build this data center over here. So I think there's going to be a lot of challenges, just domestic challenges inside countries as they start to work out how you deal with some of these things. So yeah, I think it's a really interesting kind of challenge opportunity. And then you've got policies like CSRD, which are also going to start to kick in to enforce regulations around things like emissions. Yeah, I think, was it Microsoft? I heard on the news this morning. This fascinates me again because of scale. The budget was just done in the UK. The Chancellor has just announced the budget, right? Of which there was, I think, 40 billion was raised in taxes, or that's the tax increases onto the public and businesses in order to fund the things that we need to do. So I came off the back of that story thinking that's a really huge number, right? And then the very next story was about Microsoft and how much money they've committed to building data centers to underpin AI. 50 billion. Their investment by one company is more than we have increased taxes by on our entire country. So again, I look at that and think, is the bubble going to burst with this? When there's that amount of money going in. The following story was there's Meta. Everyone remember the metaverse? Yeah, that was a thing. Yeah, Facebook even changed the company name to be Meta. Anyone use the metaverse? Anyone? No. So again, I think next year is going to be an interesting year because I think we'll see this. I think we'll see a bit of a seesaw, particularly when it comes to AI. I think there's going to be that normalization of people suddenly realizing it has use cases. It absolutely does. But I think there's going to be that normalization, and then we'll come out the other side. I don't think it'll be a .com, but having been in the industry as long as I have, again, many of you won't remember .com, but I was there at the time, and suddenly everybody had to have the internet. And it was, well, what are you going to use it for? I had no idea, but I can't be the one who doesn't have it. And when we actually went into the .com crash, there was, for those of you who were at distributors at the time, there were warehouses full of equipment that had been bought, but the .com boom or bust happened, and it never got shipped to the end users. Millions and millions and millions of pounds worth of technology was bought because people just didn't want to get left behind, but never really had a use case for it. I don't think that's the same this time, but there's shades of that when you think about AI. So yeah, there's lots of things like that I think about, which is probably way beyond anything I can have any effect over, but it still fascinates me.
So a little detail that I catched was thinking about the time frame for every wave. I recognized that the cloud one was quite long. So, and now later in the presentation, you said we are like at the beginning of the fourth wave and we see the fifth wave already coming. So what are your thoughts on why these waves take so long or eat up each other or come in parallel? Was it too complex to catch in a short time frame, all the cloud stuff that happened? So what are your thoughts on why these waves take longer or are shorter?
Great question. So I think one thing that doesn't come across, and I should just reinforce, waves don't just stop and the next one starts. There's a long tail on waves. So we're still in wave one. It's just that there's very little being spent in wave one nowadays. So it's more to do with as a new wave forms, our attention tends to go to the new wave, but it doesn't mean that the old one simply goes away. The kind of patterns that I think are happening, I think they are happening more frequently. If I think about wave one, which was sort of the 90s and 2000s, that modularization wave, that was a long, long process. And it was held back by a lot of different things. I remember speaking to, it was actually one of our reseller partners at the time. They were a big EMC Symmetrics company, so that's what they shipped. And I remember going in and talking to the guy at the time, who I won't name him, it wouldn't be fair. And I was trying to get him to realize we were in a wave and the future was going to be modularization. And I remember him saying to me, because I challenged him, I said, why won't you move? Why are you not interested in the things that we do? He said, Matt, every time I sell a Symmetrics, I sell 60 days worth of consulting. He said, when I sell one of your boxes, I sell 5. So there are things like that that inhibit changes and patterns. Cloud was very, very similar. If you think about a lot of the companies that we go and talk to cloud about, it was, we're never going to the cloud. It's not secure. It's not safe. You know, I went to Switzerland a few years ago, and the local account team said to me, because I was being brief, they said, don't talk about cloud. We are Switzerland. We're finance companies in Switzerland. Cloud, not a chance. And I went back 2 years later, said to the account team, what do we need to talk about? He said, cloud, you have to talk about cloud. Everyone's going to the cloud. And so it was kind of, so again, there's some of the things that hold this back is never technology. And technology is usually available to us way before the waves really start to form. It's public opinion, it's corporate policies, it's skills, it's desire. You know, I think one of the things that again excites me, linking this back to NetApp, typically NetApp hasn't been frightened of leaning into something that others think would be damaging to them. You know, with cloud, you know, I remember in virtualization, people saying, you know, with virtualization, it's the end of technology vendors. And NetApp said, no, I think it's the new beginning for us. I think if we lean in, people will need shared storage. And actually what people said would be the death of us gave us another 2 billion in revenue. Cloud, very similar. You know, why would we go to the cloud? That's taking storage that we could be selling to companies. It's taking that data and moving it into something we create no revenue from. Well, we're 6.5 billion now. So I think that's the other thing is, again, it's sometimes held back by companies who don't know whether it's in their best interest and can therefore stop away from forming. One thing I do think, though, is they are happening more frequently. The first wave, 10 to 15 years. I think the virtualization wave, you know, it was probably the course of 4 or 5 years where it sort of started 2007, 2008, and just boomed through the next 3 to 4 years to where we're now at a point where people are 80, 90% virtualized. I think cloud was still I think at the beginning in certain areas. We still have a lot of later adopters that are starting to come in at the moment. So I think cloud has a lot more left to go, but it's sort of changing. People are building real strategies around cloud. I think in the early days, I would say to people, you know, what's your cloud strategy? And they'd say, you know, cloud first. Well, that's not a strategy, that's a mandate. So your strategy is Amazon. That's destination. So you have a mandate and a destination, but what's your strategy? Ooh, okay. So I think now people are effectively looking at it, and some workloads are coming back out because they were mandated and they didn't go there for the right reasons. They just went there because when you're given a mandate, you just start doing stuff. And I think AI is fascinating because everybody has jumped on that train. Every person in the world has jumped on it, which is why I think it'll be an interesting year or two as we start to see that normalization where people suddenly start to realize, actually, for us, this maybe isn't the big opportunity that we thought it was. So they're all going to carry on. They all have a long tail. People will be investing in virtualization, cloud, even on-premises infrastructure for many years into the future. It's just people's attention tends to get drawn to what that new wave is. With quantum, I think the only thing that really is, that is a technology challenge. We don't have usable quantum right now, not usable for any substantial or meaningful purpose. I would say to everybody in this room, if you want to start thinking about what should I learn next, I would start seriously looking at quantum computing. You can go to NVIDIA, by the way. NVIDIA have a big investment into quantum. They even offer free training. You can go to NVIDIA's website and you can get free training for them around quantum. So I would encourage everybody, don't wait until it starts to happen, because if you wait until it starts to happen, you're already going to be 2 years behind. I think it's definitely something that people should start putting some time into. Long, rambling answer, but I'm not sure was the actual answer you were looking for, but hopefully it was something there. Yeah, I mean, we should go for a drink and just sit there for hours talking about this. But these are wonderful conversations. It's exactly the same conversation we were having here. It's very easy for us to get fixated on a technology, and actually, it's never the technology that holds us back. It's something around it. We don't have the power, we don't have the skills, we've got regulations, it's always something else that typically holds us back. Very rarely is it actually the technology. So you can start going down a route here, talking about something quantum or a wave, and you suddenly end up in all this kind of fascinating theological type discussions, because there's so many other things that you have to think about in order to be able to deal with some of these things. So yeah, great question.
And with all respect, maybe these are all ripples, not waves.
Well, so see, now look what you've done. Because you're right, something could happen that could make me look back and go, I got it completely wrong. None of these things were waves. These were all just actually bigger ripples because something else has happened.
Globalization, I would like to look at it as maybe a bigger wave. So humankind is kind of standardizing on something.
Yeah, when I was putting all of this together and I was starting to look at future things, you think very differently when you sort of step back and really consider these things. Somebody were talking about what's the evolution of cloud, and and this kind of takes a little bit of your point, to be honest. Okay, what is the evolution of cloud? If we can't build 90 data centers in Ohio, where do we get the processing power from? Well, there's how many millions of Teslas on the road right now? Several million being used for what, 1-2 hours a day? There's more compute power in those systems than there is in 90 data centers. Using tools like WebAssembly, what if we could tap into the unused compute resources of your phones? We've done it before. Anyone remember SETI, the Search for Extraterrestrial Intelligence, where you could contribute, there you go, you could contribute some of the processing power of your laptop, of your device, into the project to compute and find the search for extraterrestrial intelligence. Why wouldn't that happen again?
At the same time, this energy, which is required in Ohio, spread out throughout the world, right?
Yeah.
So the problem is just spread out. If, for example, a lot of companies probably would like to use unused mobile phones or Tesla or whatever, but probably it doesn't solve the problem. Globally.
It probably postpones it for a short period of time, but it does. It goes. You start to get into those fascinating what if type conversations. Because, there's an awful, if you think about how much compute power is in this room at the moment, with all of the phones, hopefully none of you are using your phones at the moment. I've failed if you are using your phones. That's a lot of compute power. And you've probably all got an iPad, or you've got a laptop, or you've got something. There's a lot of compute power in this room that we're doing nothing with right now. And you have to look at that and think, there's got to be an opportunity there somewhere, especially if we have the kind of tools, containers, functions, WebAssembly. If we have those kind of tools, could we tap into those things? And you think about it, one of the big challenges that we have is latency with the cloud, right? Because the cloud locations are typically further away from where we are. So you've got a level of latency. There's a Tesla in the car park. If I've got a problem that I could submit to a cloud of Tesla devices that could select the one that's nearest to me, I've got a microsecond or millisecond latency to the one that's down in the car park outside. So suddenly you start to solve for the location problem as much as you do the compute problem. It's very hypothetical, but it's the kind of discussion that fascinates me, because I think if we haven't got the power, or it's going to take us a lot of time to build the power that we need, then where do we find the resources from? And I find that interesting.
This is quite nice discussion. But for example, if you would ask me if I would like to allow my phone to process. So for example, nowadays I charge phone in the morning or through the night and I assume it will work throughout the day without any charging.
Yeah.
And if I would allow, then in an hour, probably my battery will be dead.
But we can...
the problem of recharging, so it's, again, the same is with Tesla.
Yeah.
Okay, so the problem of this Ohio, this with energy, putting on users, which somebody should pay for this energy.
Yeah. Yeah, it's a good point. And there's so many, those are the things you would have to solve. You know, one, there would have to be an opt-in. Two, you'd have to have parameters that says maybe it only happens when it's on charge, or so. And people have also put the argument about there of, does it reduce the life cycle of my technology because of course it's under load, and how much am I going to get paid for it? And I think if you can solve for those problems, there's a lot of people that would say, actually, while my phone sat by my bed at night on charge, if I can be earning money from my phone overnight, maybe that's interesting. So it's a great point. And again, it goes into one of those really interesting discussions of how do we, one, put the technology in place to enable it to happen with the parameters around it that says, actually, I can't make your phone die during the day because I'm using the resources. And then a commercial model that says, but what if I pay you for it? So I think, then you get into all sorts of things. Do we have enough power to compensate for the amount of extra charging that we're having to do? That's way beyond my level of intelligence. You have a question?
Yeah, so last question. My question is, do you think that the fourth wave is just like an artificial wave? I mean, the three previous waves are like very necessary to store the data. But do you think that the fourth wave is just like a trend?
The fourth wave,
Yeah.
you said, yeah?
So the last wave, AI.
Yeah. So
Because it's not necessary, I think. From my point of view.
yeah, no, that's fair enough. I think when I look at again, there's never that one sign. I wish there was just a kind of a set of signposts that could point you at something that you go, that's clearly a wave. So you have to just look at a whole bunch of different data points. I think one of them is the amount of money that's being invested. When you've got Microsoft putting 50 billion into AI, when you've got Meta, I think they were 30 or 40 billion. When you see that level of investment, when you witness someone like, you know, NVIDIA stock, I was met a guy at the weekend. Sorry, slight tangent, but it just reminded me of it. I met a guy last weekend, and he pulled up to me in a Ferrari. And so we got chatting, and he said to me, what do you do? And I said, I'm the sort of chief technology evangelist for a tech company. I said to him, what do you do? And he said, well, I used to be in the armed forces. I'm thinking, fuck me, they pay well. He said, I had some money lying around. He said, when I came out of the forces, he said, I had this little bit of cash. It wasn't very much. He said, so I did research on a whole bunch of companies thinking I'll make a little bit of an investment. He said, and I chose NVIDIA. He said, and now I have a Ferrari. And so that was one of those moments of, my God, you know, if a company like NVIDIA can reach the level of market capitalization that they've reached because of AI predominantly, that's a signal as well. And then it's conversations. Every conversation that I have with everybody is about AI, is about use cases for AI. So, but who knows? Maybe we will look back on this and say, what were we thinking? You know, you could, in those waves, I could have put .com, I could have put internet. You know, so yeah, it's an interesting one. And I think at the moment I feel it is, because it's unlocking so many job opportunities, so much investment. But who knows? We could have this conversation in 5 or 6 years' time and say, what on earth were we doing? But I'm fairly sure that we won't. I think it is significant enough. There's too many things happening, I think, for it not to be a wave.
All right. Matt, it was great having you here. Thank you very much.
Thank you very much.
We ran way over time, but that's due to it's an honor to have you and talk to you and hear your thoughts. Will you be around a little bit more?
I will be here for another. Oh yeah, we have run over. I'll be here for another couple of hours. Yes.
Couple of hours.
Couple of hours.
Okay.
Yeah.
So in the next pauses, we will grab you somewhere.
Fantastic.
Thank you very much.
Thank you very much. Thank you all very much. Really fantastic. Thank you.